Hello everyone, myself Ani Sharina from Sri Venkateshwara College of Engineering, CSEI branch. Today we are going to discuss about closure properties of context-free level language. Let us introduction of context-free level language. Context-free language are formal language that can be generated by a context-free grammar. A context-free language is also denoted by CFL. They are essential in field of computer science, particularly in processing and programming languages. Understanding these closure properties help in analyzing operations that can be performed on these languages. Let us discuss about definitions of closure properties. Closure properties refers to the ability of class of language to remain within the same class when subjected to certain operations. For context-free language, these operations include union, concatenation, and nil star. Knowing closure properties allows for construction and manipulations of closure context-free languages with predictable outcomes. Closure under union. So as we see in previous slides, we saw that there are different kinds of closure property. The first closure property is union. So what is union closure properties mean? Context-free level language is closed under the operations of union. As we know, let us take as an example L1 and L2, two context-free free language. Then L union L2 is a context-free. Let me take an example. Let me say L1 has uh, the integers like 1, 2, 3, 4. In L2 we have 2, 3, 6, 8. Now when we do union, the similar part like 2, 3 is present in both L1 and L2. So the union of L1 and L2 will be 2 and 3. This property is useful in constructing new languages from existing one by combining them. Closure under concatenation. The concatenation of context-free language is also called as context-free language. Now this is the second property of closure property. So specifically like if we L1 and L2 are context free, then the L1 and L2 is the concatenation context free. Like as I said, like L1 has 1, 2, 3, 4 and L2 has 5, 6, 7. So the concatenation of L1 and L2 will be 1, 2, 3, 4. No. The first and the second one. So first is in L1 we have 1 and in L2 we have 5. So 1, 5, 2, 6, 3, 7 and 4, 8. This properties allows for creation of language that consists of string formed by joining strings from two context-free languages. So this is not maybe applicable for integers. It is mostly used for in strings or characters. For example, L1 has A and L2 has B. So the concatenation of L1 and L2 will be AB. So the third one is closure under nil star. So the context free language are closed under the nil star operation. If L is the context free language, then L uh, is also called as context free language. The set of all string formed by the concatenating zeros or more strings from L is known as nil star. Non-closure under intersection. So Now we have seen the closure properties. Now we are going to see the non-closure under the intersection. So the first one goes like intersection. Context-free language are also like not closed under the intersection with attributary context-free language. This means that the intersection of two context-free language may not be held by a context-free language. For example, if intersection of language A power n, B power n, C power n where n is greater than 0 with another CFL, which is a non-context free language. The languages for this questions goes like A, B, C. If we give the n value as 1, what if we give n value as 2? Then the values goes like A, B, B, C, C. If we give n value as 3, then the values goes like A, 3 A's, 3 B's and 3 C's. Non-closure under complements. Context-free languages are also called also not closed under complications. The complement of the context-free language may be context-free. This is particularly important when considering the limits of CFLs and certain complementations applications. Closure under homomorphisms. The CFL are closed under this homomorphism, which transfers string based on the defining mapping. If L is the context-free language and H is the homomorphism, then HL is context-free. Okay, if in L has some variable and H also some variable, so the both are context-free language. This property also allows the transformation of language characters while preserving the context-free status. Closure under inversion. The context-free language are closed under inverse homomorphism. If L is context-free and H is homomorphism, then the inverse of H power 1 minus 1 L is also known as context-free. This property is used for analyzing the language through the lens of mapping and structure. Summary of this closure property is context-free language exhibits closure under several operations such as union, concatenation, nil, star, homomorphisms, and inverse homomorphism. However, they do not maintain closure under intersection or complementation. Understanding this property is vital for theoretical computer science and development of compilers and interpreters. Thank you. Hope you enjoyed or learned something about the closure properties. Please like and share. Thank you.